Did I start instruction set on that day? Anybody reply, no? Okay, I'll just make a glance. Okay. I actually arithmetic instruction I completed. I hope anyhow I'll make it fast. Okay. See here architecture of 8086 we have completed. Instruction set of 8086. Instruction means is a specific task we are assigning to your processor. It's called instructions. Okay. Group of instructions are called the instruction sets. We have more than here 20,000 instructions in 8086, but all the 20,000 we are not going to study. Okay. The very frequently used instruction for writing program alone we will see. Okay. So it is classified as data transfer instruction, arithmetic, bit manipulation, program execution, string and control. Okay. Okay. First we will see data transfer instruction. What do you mean by data transfer instruction? See, actually for when you're writing a program, no, high level program you know how to write, right? Now here, right? So you have to know the instruction for doing addition, subtraction, logical, comparison, everything you have to study, which are grouped in one category. And this data transfer instruction means data transfer means from location to analog. So where to where data transfer? From processor to from memory to processor. Otherwise, from processor to input device and output device to processor. Okay, this is where your data will be transferred. So you should have a special instruction for data transfer. The very important is move instruction. This is data transfer between processor to memory, memory to processor. So in the program you will be using, and you can see that any instruction means it is going. Ma, can you hear my voice?
Yes, ma'am.
Okay. Any instruction means, see for example, MOV move DES, SRC. Any instruction means first will be your opcode followed by your operand. Opcode is what? MOV. MOV means it tells you you're moving some data from one location to other. DES, SRC means it is an operand. DES means destination register. SRC means source register. In this place, you can use any register like general purpose like AX, BX, CX, no, DX, any register you can use, right? So here I have given the examples here. Move CX, 037U. So what you're going to do here? So in this example, what? In this example, 037A is your data. That data you are moving to the register CX. So 037A is a source, SRC, position. CX is the destination. Okay. See the another example. Move AL, BL. So what here you are doing? You are moving the data or copying the data from BL to AL register. Okay. Okay. What is the third one? You see the third one? Move BX, bracket 0301. What is the difference between first instruction and last instruction? First instruction, if last instruction tells you it's a memory location. When I put a square bracket, inside square bracket, if I am writing 0301 means it is indicating address. Within square bracket means address. From that memory address, what data is there? You are transferring the data to your processor register BX. Is it clear, everyone? This is the simple move instruction. See next, no. Suppose if you want to do stack operation, move data from stack to processor and processor to stack means you can use push and pop instruction. Push instruction means push BX. See, this is single operand instruction. You don't have BX, AX and all, right? So BX, so it is single operand instruction. Push BX means what it push BX into different in BX. you are trying to move it to your stack. Okay. Suppose if you want to read from your stack, means what you can do? Pop. Okay. See here. Example. Pop AX. So what it is going to do? It is going to read from your stack. That stack is pointed by your stack pointer SP. Stack pointer. Okay. Pop AX means from the stack pointed by your stack pointer, you are going to read the content and move it to your AX. Okay. See the next instruction. Exchange instruction. XCHG. What this instruction is going to do? This instruction is going to swap the content of DS register, SRC register. XCH DX, AX means, for example, DX is having value 5. AX is having value 10. So what this instruction will do? It is going to swap the value. After the execution of this instruction, if you see the content, no, in DX register you will have 10 and in AX register you will have 5. Okay. So this is the function of an exchange instruction. This is also one type of data transfer, right? So keep it in your mind, when from processor to memory or memory to processor you want to transfer data, means MOVE. Okay. And in and out instruction is there. This instruction, what it will do is, it is going to, we are going to use this instruction for transferring data from processor to input device and from output device processor. See here example, in AX, 0028. What is 0028? It is not data. It is the port address, input port address. So what the processor will do? From this port address, it will read the content and it will store it in your AX. So from where to where? From input device to your processor. What is your out port address, accumulator? Out 0028, AX, what it will do? It is going to transfer the data which is present in AX to your destination. Destination is what? The output address, output port address, where your output device like display unit is being connected. Okay. Is it clear here? In and out instructions you are using. Here definitely in and out instruction, we should use accumulator AX only. We cannot use any other register. You cannot use DX, BX, CX and all. Okay. This is not necessary. It's very high. See the second set of instructions. Arithmetic instruction. See, these all are self-explanatory only. But you have to know the opcode. Opcode means what? In high-level language, where C A plus B you will do, right? So you know that C equal to A addition, right? So for example, A and B, 2, 3 means what it will do? 2 plus 3, answer 5. 5 will be stored in your register, variable C, right? In assembly level, you cannot use variable, you have to use register, okay? So add destination, source means give an example. See the first example, add AL, 74. What this instruction will do? It will add AL plus 74. What answer you have got, it will store in your AL register. For example, your AL is having 02. So what this instruction will do? 74 plus 02, the answer is what? 76. That 76 will be stored where? It will be stored in your destination register AL. Is it clear, everyone?
Yes, ma'am.
Okay. So this is called immediate addressing mode. Why means immediately the data is specified in the instruction. So it's called immediate addressing mode. Second example, you see, add dx, bx. So what this instruction will do? The content of dx plus the content of ax. So dx plus ax, what answer you are getting, that will be stored in your dx. For example, dx is 10, ax is 5. On adding 10 plus 5, the answer is 15. Where the 15 will be stored? It will be stored in dx. Okay, make it clear. This common mistake many will do. Because dx is the position of destination. That's why in the general format, I have given ADD, opcode, DS and SRC or the operand. Okay. So source operand, destination operand. So after addition, the result will be stored in your dx. See the next one. Add ax comma within bracket if I give bx means what? It is a pointer. Whenever I use a bracket, it represents the memory location. So I am going to add two values. One value is present in ax. The other value where it is present? It is present in memory. So the memory is pointed by what? A pointer bx. Okay. So bx will point to the memory location. In that memory location, whatever data is there, that you are going to add with your ax. Okay. Simple thing only. Okay. See the second point. I am telling it a data transfer instruction does not affect the flag. Flag, totally how many flags are there? How many flags are there?
9, ma'am.
Totally we have 9 flags. 0 flag, carry. These 6 flags only they are conditional flags. Whereas the 3 no, trap, directional, those flags are the flags we are not going to use in the program. Okay. So why I am using the term it affects the flag means where is the flag register located? The flag register is located below the ALU unit. Why means after the execution of any instruction, depending on the result, if you go and see in your flag no, if that particular bit will be set or reset. Set means it will be 1. Reset means it will be 0. Example I will give you. This is an add. See, when you're trying to add AX and DX, if you get a carry from your MSB, so what will happen? Your carry flag will be set. That means in CF position in the flag, if you go and see means it will be 1. Okay? It's one example. I will tell you next. See, next instruction is addition with carry. So ADC. ADC means add with carry. What it will do? ADC CL plus comma 74 means it will add AL plus 74, and if it gets a carry, along with the carry it is going to add plus once again. Along with the carry, okay, along with the carry, it is going to add. Okay. Similarly, for doing subtraction, see in your program, small programs you will be doing in microprocessor, right here, assembly level program to add two values. Okay, which is present in memory or register. Similarly, write an assembly level program to subtract the two values. These are the small programs you can see in lab. In that case, what you do? You need the instruction for doing subtraction. So SUB, destination comma source. So SUB means it is going to subtract. So SUB AL comma 74 means what it will do? AL minus 74, and the result will be stored in AL. Similarly, SUB DX comma AX means it's a timing lesson. இவங்க மகாமேம் கேளுங்க சீக்கிரம் போன் பண்ணி கேளுங்க அவங்க வச்சிருப்பாங்க சார் ஒரு நிமிஷம் கேளுங்கம்மா மீட்டிங் ஸ்டார்ட் ஆயிடுச்சா சார் மீட்டிங் யார் சார் பிரசன்ட் பண்றா Okay, SUB DX comma AX means what you will do, you are going to subtract. So AX minus DX, answer will be stored in DX. For example, I'm giving, if AX is 5, BX is also 5. So what will be the answer? What is the answer? But nobody are there, huh? My students are there?
Yes, ma'am.
Yes.
What I told, what I asked now?
Sub of dx comma ax.
The value of
10
AX and DX are 5, 5. So what is the answer? No, I didn't ask something very big, ma. Subtraction. 5 minus 5, it is 0. Answer is 0. Okay?
0.
So what will happen? You have the flags, no? If I go and see there is one flag called ZF. You see there in second statement? ZF. So 0 flag. Okay. So what will happen in ZF, no? ZF, the value of ZF will become 1. So what the processor will do is, after the execution of subtract instruction, if it goes and see the status of ZF flag, there it will be 1. So processor will understand that AX and BX, DX, both the value are same. So where you can use this flag, you can use this flag in if conditions. In high level, you will use if, no? Is it not? So if high level, you write if A is greater than B, do some operation. Otherwise, do this operation. This is the program actually. Okay. In assembly level language, you cannot use if or for or switch. Nothing you can use, right? So you will you use a compare instruction. After that, processor will go and see this flag only. Flag only I will use. I have some instructions I will teach you. JZ, jump on 0. JNZ, jump on no 0. That means what? Like you cannot write if greater than A and all. What I will do? After subtraction, if I get the value is 0, I will use the instruction jump on JZ. That means what? Jump on 0. Right? That means when the 0 flag is set, what is the meaning? A, the value of dx and bx are equal. That means the condition is if A is equal to B. Right? So conditional instructions in high level, for in assembly level, we cannot use the conditional instructions. We will be checking the flags only. Like condition, I'll tell you some conditional instructions here. JZ, J and Z. Similarly, CF. Similarly for over. Sign also I have some instructions. Okay. This is subtract with borrow. So till now we have seen move instruction for data transfer, push instruction for transferring data between your processor and stack, in and out instruction, data transfer, okay, from input and output device to processor, and arithmetic instruction, add instruction, ADD, ADC add with carry, SUB subtract, similarly SBB subtract with borrow. Examples you see, okay. And the very important instruction is INC, increment. INC stands for increment. For example, you will write like this, no, A is equal to A plus 1. Right? Or you will write in for loop I plus plus, increment. Right? Similarly, I minus minus, decrement operator. So in that case, where you will be using is in looping or wherever you want to do the operation. Many times you'll be using their counter for incrementing or decrementing for checking the condition, etc. Right? So in assembly level language, instead of add, no, we are having the instruction like increment instruction. So what this instruction will do, see for example, INC AX if I put, consider the value of AX is 5. INC AX means what will happen? What will be the value of AX after the execution of this instruction? Ma, I am not teaching something very difficult. Okay, already you know high level language. I am teaching 40 years before what they were using assembly level. That's it. Okay. I gave you the example also. I is equal to I plus 1. The equivalent assembly level language, you can use I increment instruction. Consider if AX is 5 means, INC 5 means what will happen? AX.
6, ma'am.
That's it. Okay. So you'll be using this INC instruction frequently in a program for suppose I ask you to find out the largest among n number, the lab program, smallest among number, arrange in ascending order, arrange in descending order. Okay. So looping counters, right? Those plays, no, this instruction you'll be using. Okay. In lab you'll be using. Similarly, decrement. Okay. I minus decrement instruction. So DEC. DEC AX means AX minus 1. See, these instructions which I am going to tell will be used in code conversion. You will also have a program for code conversion, ASCII, then BCD number code conversion, decimal adjust accumulator. Okay. As of now, you just go through these instructions alone, because in exam, no, if they ask you the instruction set, you first tell what is instruction, how the instructions are grouped into various categories, and explain 3 or 4 instructions with example. Okay. So this is also coming under the arithmetic instruction like code conversion. AAA means ASCII adjust after subtraction, after multiplication. AAD means after division. Similarly, when you want to convert into decimal numbers, right? Because whatever number I am specifying in examples are hexadecimal. Assembly level language means operations will take place in hexadecimal only. So 0 to 9 and A to F. Okay. Suppose after adding two hexadecimal number, I want to round it off. I want to make it as BCD number, because when I add hexadecimal, definitely you will have A, B, C or F, 2, etc. I want to adjust them into BCD means I can use this instruction. DAA, decimal adjust accumulator. DAS, decimal adjust after subtraction. As of now, you remember this. Why you need DAA? Okay, because when you try to add two numbers, for example, add AX comma BX, if I use it is hexadecimal addition only. So hexadecimal addition of A to F. Okay, so I want only the PCD means what I will do is I can use this instruction DAA. So it will automatically, what it will do is it will adjust them into BCD. That for adjusting also there is some steps. Okay, this is negation, NEG. You should know all these things: ADD, ADC, SUB, SBB. Okay, then DEC, INC, then DAA, DAS. So these are the opcodes you should know first. And you should also know whether it is one operand or two operand instruction. One operand means push AX, only one operand AX is there. Whereas for arithmetic instruction and all, no, most of the instruction two operands. See here, add AX comma BX. So AX is one operand, BX is other operand. Similarly, subtract means SUB, DX comma BX. So two operand. Okay. So you should know which instruction is having one operand, which is having two operand. That you have to read. And you have to know that opcode. You should not make mistake in opcode. NEC means, INC means increment. DEC means decrement. That you should know correctly. Similarly, NEG. NEG means what? Negation. Suppose I give you a value. I am asking you to find out the 2's complement. So how will you find out 2's complement of a number? For example, 0, 5 I am giving. So how you can represent 0, 5? 0, 0, 0, 0. Then 0, 1, 0, 1. Okay? Right? That is the equivalent of 5. If I am asking you to find out 2's complement of 5, what you will do? First, you have to take 1's complement. After taking 1's complement, add 1 to that result, you will get 2's complement. Okay, that is the 2 steps you have to do. So how will you find out 1's complement of your number? Just inversion. Wherever 0 is there, you have to do 1. 1 is there means 0. After that, add 1 to that. That is the regular step. Okay, 2 step is needed. So in the place, wherever application where you want to find out 2's complement, what you can do, you can use this instruction, NEG. NEG, SRC. SRC, AX you give. So NEG, AX. AX value 0.5. So take the 2's complement and see. Directly this instruction will give the 2's complement of your number. Okay. Otherwise, what you have to do? You have to write 2 steps. First step is find out 1's complement. After finding out 1's complement, add 1 to that. Okay. So 2 step is required. But here we can use a simple instruction NEG, which will find out the 2's complement of your number. Okay. Next, you see this is very, very important instructions. Why I'm telling you is there are a lot of instructions. All the instructions you are not going to use in lab for writing the program. Okay. The instruction which I'm teaching now, that alone you prepare. Okay. When you go for MPMC lab, just go prepared. Okay. Don't go and sit and blink there. 8086 means how many data lines? 16. Address lines 20. How many registers? 13 registers. 14 registers, sorry. How many segment registers? 4. Code segment, data segment, stack segment, extra segment. How many general purpose register? AX, BX, CX, DX. Okay, how many flag register? So these are the basic things in 8086. So when you go to the lab now, please prepare that and go. Don't go simply. Okay, and also study the instruction set and go. Only then you can do the lab. Okay. See this compare instruction. See high level language. I told you, you can use if instruction. If A is greater than B, or A is less than B, or A is equal to B. Depending on the condition, you're going to write the program. Okay. As a programmer, if you write this now, automatically your high level will be converted into an assembly level language. Which instruction? If instruction will be converted to compare. Okay, this automatically your compiler is doing. So you don't know. Compiler, assembler, interpreter, no, is doing this job. So as a high level programmer, you don't know what is happening internally. Okay, high level programmer is flexible. That is the reason. Okay, you learn the high level program. So C or C++ or Java, whatever may be, irrespective of what processor, no, you learn that. Assembly level means it's very difficult. Depending on processor to processor change, no, you have to study its instruction set, and the program is very lengthy, and debugging also it's very, very difficult. But one advantage is the time for execution is less, because already we have coded, right? So it will be less. No, otherwise it's very difficult. Clear? So compare. What this instruction is doing? It is comparing two registers, DS and SRC. Okay. So if I give compare BX comma CX, how the compare? You see, if I give two values to you, compare AX comma DX. AX is 20, BX is 30. By seeing, you can tell easily that BX is greater than AX. Okay. But a processor cannot see and tell. Right. So what the processor will do? How it will compare the two values, two registers? It will do subtraction. Okay. What it will do? If I give comparison also, internally what the processor will do? It will do subtraction. It is going to subtract these two registers. If you get answer 0, what will happen? In 0 flag, 1 will be set. So processor will understand, okay, A is equal to B. Okay. If you subtract, if your what a 0 flag or a sign flag, not 0 flag, your carry flag in case will be set means you can tell it's for a borrow, right? you can tell that B is greater than A. If you get a positive number, in that case, you can check your sign flag. If you get a positive number, it will tell you that A is greater than AX is greater than BX. Flags are used for conditional. See, these two instructions today I will tell you. Okay, multiplication and division, then we can wind up. See, very, very important is your processor is 8086 processor. Before 8086, the generation was 8085 processor. Okay, that processor, in that instruction set, you didn't have instruction for multiplication and division. Okay, 8086 only is having an instruction, generation I'm telling. It is having multiplication and division instruction. Okay, it's very, very simple. See, multiplication means it's going to multiply. Multiplication means it is going to do the multiplication instruction operation. Okay. So what? See here. When I give MUL, SRC, what is the meaning is, for addition, how I'll give? Add, ADD, AX, BX. You need two operand, AX plus BX or CX, DX. Whereas for multiplication, it is one operand only. I will specify here, MUL, SRC, like MUL, BX, I will specify. Okay. So you can ask me, if I want to multiply, I need two values. BX you are specifying here. MUL BX you are specifying. With what value I have to multiply? Accumulator. It is understood. Okay. When I give MUL BX, it is understood that I have to multiply AX into BX. If suppose if I give MUL CX means, what you will do? AX into CX. Okay, it is understood. One of the, what is that? Operand is your accumulator. It is implied. Is it clear, everyone? That is the reason. You can see here, you can see the example which is given here. Very simple thing. If I give you MUL, listen carefully, MUL BL, if I give, what is the meaning? AL into BL. Is it not see this example? Two lines is given. Here what I have given is AL into SRC. In the place of SRC, no, you can have BL or you can have CL, anything you can have, right? So what you're going to do? For example, if it is BL means what you will do? AL into, in the place of SRC, it is BL. So it's just a multiplication only. Okay, you're not doing anything great and all. Just you're multiplying two values. AL into BL. Okay, where the answer you will store? That is there, right? The answer will be stored in your AX. This point only very, very important because in lab, you will execute the instruction. But for seeing the result, no, whether you have to go and see your AX register or BX, you have to know carefully. Okay. So when I write an example, MUL BL means AL into BL, where the answer will be stored? It will be stored in your AX. That means what? First example is AL, 8-bit multiplication. When I multiply two 8-bit will be green. Okay. See the next one. Next one only you should understand. Next one, carefully you will see. Next example I am taking. MUL. First example, if you want, write in the paper. First example, MUL BL, if I give means AL into BL. L means lower, 8-bit, 8-bit. So answer will be greater 8-bit, so AX. Second case, what? BX. BX, if I specify, it is 16-bit value. So AX is 16-bit, BX is 16-bit. So if I multiply 2 16-bit, definitely the answer will be greater than 16-bit. For example, you consider it is 32-bit. Can you store 32-bit in the AX register? Single register is sufficient? No, because AX can hold only 16-bit value. The remaining higher 16-bit value, where you will store? You need some location, is it not? That is why DX is used here. In the left side, you can see that. DX colon AX is equal to AX into BX. So AX is one 16-bit value into, in the place of SRC, if you have BX means AX into BX, if you multiply 2 16-bit 16-bit, if the answer is 32-bit, 32-bit value cannot be stored in single AX. That is the reason they have used here like this, DX colon AX. What is the meaning? That 32-bit, if you get the answer, means higher 16-bit will be stored in DX and lower 16-bit will be stored in AX. Is it clear? That's what it will be shown in the second line. It multiplies 2 bytes to produce a word. Bytes to word. Byte means 8 into 8 word. Or 2 words. 2 words means 16 into 16 to produce a double word. Word means here it is 16-bit. Okay, byte means 8. Okay, first example, 8 byte by byte, if you multiply, you will get word. So a word means 16-bit. Your AX is also 16-bit. You can store the value. Whereas the second one, word, 2 words, if you multiply means, that means 16 into 16, if you multiply means you will get double word. Okay, double word means 32-bit. 32-bit you cannot store in AX. That is why you are taking the help of DX is also there. DX, see this 2 line, no, you should understand, very, very important. Okay, just see this. In the place of SRC, no, you can write BX combination or CX combination or DX combination, anything you can write. This is the general form. SRC means don't take it as register. The word, they're giving source. In the place of that, you can write BX or CX or DX, anything. Is it clear?
Yes, ma'am.
Division I will complete, okay? Then you can go. DIV SRC means it is division. Say when you divide a number, okay? Example I can give DIV BL. So what you will do? AL divided by, it is understood that AL is the numerator, denominator is BL. Okay? What you are doing? When you divide AL divided by BL, definitely in division you will get quotient and remainder. Okay? When you have double word by byte, if you divide, you can have your quotient and the remainder in this. See this is only very important. In AL, quotient will be, if you cannot change this. In AH, remainder will be. That's it. Okay? So when you give DIV, AL, BL, sorry. So AL divided by AX divided by BL means the answer, for answer of any division is quotient and remainder only. So where the quotient will be stored? In the lower half of your AX register, that is AL. Where your remainder will be there? Remainder will be in AX register only. Which part of AX register? AH. Here L means lower, H means higher. Okay? See, after that we have bit manipulation and all. But tomorrow I'll try to complete the instruction set. Okay? We are framing the timetable. Okay? For 3 days online and 3 days offline. Okay? And I will also circulate how the timetable is going to be. in offline classes, first 2 hours we'll have class for the tough subjects. Okay, being third year, maths and TOC will be having, and remaining hours will be having for what is that, laboratory. Okay, 3 labs you have, right? We'll be accommodating that. Okay, that is our plan, and we are putting timetable. Once it is confirmed, now I'll circulate by today or tomorrow. Okay. Okay, everyone.
Okay, ma'am.
Okay, ma'am.
Okay. Have you all paid your fees? Because before 9th, you're supposed to pay your fees. Only we have to enroll your name in the database, because we are autonomous, right? So as in when you're paying and payment slip we are receiving, no, many have paid. This time it's very good compared to last time. No, last time we keep on asking. This time good response, right? So we are half of the class we have enrolled for all second year, third year, final year. No, many are doing fast. Okay, so try to complete it quickly. Okay, okay, because not full year fees. Now we are in third year, no, 5th semester fees. Try to pay it. Okay, because that's why I asked all the mentors to follow you. Right? Please respond to the mentor and do it quickly. Because out of 121 in third year, half payment is almost fine. Okay, half students, remaining half only are there. So remaining 60 students are there. So make it fast by 2 more, including today. No, 3 days are there. Please complete it. Okay. Okay. Please talk to your parents again and complete. Anyhow, the mentors will convey that. Okay. Thank you, students.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.